Good? Test, test, test. 1, 2, 3. Okay, so advanced factoring. Advanced factoring is building on basic factoring from grade 10. So there is partially an assumption that you are good at basic factoring. Basic factoring has 5 main types. Okay? There is common factoring. Difference of squares. Easy trinomials. I don't know why I went in this order. Shiza. Hard trinomials. And grouping. There is an easy way to recognize which type it is. That is by counting the number of terms. Okay. Common factoring should always be done first. So no matter what, you're always going to think about whether you can common factor or not. Difference of squares has 2 terms. Easy trinomials have 3 terms. And a is equal to 1. A is the leading coefficient, the number in front of x squared, or the number at the very front. Okay? Hard trinomials has 3 terms, but a is not equal to 1. And grouping has 4 terms. But it can also have 6 terms, but that's in advanced factoring. Okay. All right. So we're just going to run through examples of common factoring, or through examples of all of these. So for example, if I have 3x squared minus 6x, okay? What you do is you pull out what's in common. Factoring is the opposite of expanding and simplifying. So we're going to create an expression that if we expand and simplify, it would take us back to the original. So what's in common between 3x squared and minus 6x? What's in common between 3 and negative 6? What can you pull out? Yeah, you can pull out a 3. And then in any expressions or any variables that they have in common, you take it out to the lowest exponent. Yeah, so it's 3x. Then you divide. You think, what is 3x squared divided by 3x? So 3 over 3 is 1. X squared over x, we just did exponent laws, you would subtract, so 3x. Then, when you take this and you divide this by 3x, you get minus 2. If you were to expand and simplify this, you would get this. It is the opposite. So if you were to expand and simplify 3x times x, you get 3x squared. If you get 3x times negative 2, it makes minus 6x. Okay? Next, very common mistake. If I give you 3x squared y minus 3y, what is in common in this case? Yes, you can pull out a 3y. Okay. When you pull a 3y out of this, you're left with, you're left with x squared. The most common mistake that's made here is when you pull 3y out of negative 3y, it is not nothing. It has to be minus 1. Because if you are expanding and simplifying and you multiply 3y times, and you don't have a second term here, when you multiply 3y times minus 1, you will not get back to the original. Okay? That is a common mistake. This is another common mistake. What do we do here? Sorry, 2 plus 4x. Why? Descending order. It's not in the correct order. Before you factor, always, the first step is not to common factor first. It's actually to put it in descending order. So this has a degree of 1 because the exponents on it, on the variables, is 1. This has no exponents, or no variables, I should say. So it should be 4x plus 2. It needs to be in the correct order. Then you can common factor a 2 out. And you're left with 2x plus 1. You have to remember that plus 1. Okay? How do I factor this? You have to put this in descending order. This is tougher, though. What is the correct order for this? Well, first you go by degree. So the degree of this term, the sum of the exponents, like there are 3 terms here. 1, 2, 3, because terms are separated by plus or minus signs. So this is an exponent of 2 on it. This is a sum of the exponent on this. You've got a 1 and a 1, so that's 2. And then this exponent on it is 2 as well. So all of them are tied in terms of degree. When they're tied in terms of degree, then you go to alphabetical. So alphabetically, what comes first? This, or this? Yes, they both have x's, but this has a more powerful earlier letter in the alphabet. So it should be negative 4x squared plus 2xy minus 6y squared. For the record, you can still factor this, but I'm just trying to demonstrate common factoring. All right, next trick though. So here I was just pointing out a basic one. Here I was pointing out to remember that the 1. Here I added on the fact that, don't forget that you've got to have it in descending order. There's something new about this that's not just descending order. So what can I common factor here? Yes. Anytime the first term is negative, you have to common factor out a negative. So you don't common factor out a 2, you common factor out a negative 2, which leaves you with 2x squared minus xy plus 3y squared, which might look like you can factor, but you cannot. Because you're not allowed to have negatives here. If I did not take that out, I would have had negative 4x, or negative 2x squared. You're not allowed to lead with a negative inside the brackets. Okay. Let's get harder. What if I get 6a plus b minus, 6a plus b minus 2a plus b. Okay. Oh, fudge. There's no a there. Yeah, 6a plus b minus 2a plus b. How many terms are there? How many terms are there? The options are either 2 or 4. Are there 2 terms or 4 terms? Terms are separated by plus or minus signs, but when a plus or minus sign is contained within brackets, that does not count. So this is the first term. This is the second term. So there are only 2 terms. Between those 2 terms, what's in common? You have an a plus b on both, but before that, two. Yes, you've got a 2. So you can common factor out a 2a plus b. They both have an a plus b quantity. Whenever you common factor out your greatest common factor, you open up a bracket to tell me what's left over. To figure out what's left over, to take out what's left over, you have to divide. So this divided by this, you took, from this term, you took out a 2, so you're left with 3. You took out an a plus b, so you're left with an a. From here, yeah, minus 1. You took out a 2a plus b, but you cannot leave it blank. It's got to be minus 1. That is how to factor that. So that's common factoring. Remember how to find your greatest common factor. Don't forget to write a 1 if necessary. Needs to be in descending order. If there's a negative, you have to common factor out a negative. And common factoring also involves quantities, which leads me to my next type, which is actually grouping. Okay, we'll jump over here. Grouping is for 4 terms. Grouping is also called triple common factoring, because what you do is you common factor 3 times. An example of that would be x cubed, let's go minus 2x squared minus 4x plus 8. What are the first 2 things you'd ask yourself before factoring something? What's the first thing you would ask? Is it in descending order? It is. Okay. Are there any common factors between all 4 terms? No. You don't have an x in every term, so you can't pull out an x. You don't have a 2 in every term because you don't have a 2 here. So now this is grouping. Grouping, you common factor 3 times by common factoring the first half, common factoring the second half, and there should be another common factor there. When you common factor, don't put brackets around this. That's a bad habit. If you want to guide yourself, you can put a little line here. Okay? Do not put brackets around it. Does not mean the same thing. It's bad habit, bad form. All right, so what you do is you just common factor. So what's in common between, we're ignoring this half. What's in common between x cubed and negative 2x squared? Yes, you can pull out an x squared. When you pull out an x squared, what are you left with? X minus 2. You're doing division, right? Because negative 2x squared divided by x squared is negative 2. Then you look at this half. What's in common here, Mox? Negative 4. Because the first term is negative, you have to pull out a negative. And you're left with an x minus 2. Okay? Here. Now this is exactly the same as this. You have, between these 2 terms, this is 1 term, this is 2 terms, you can take out an x minus 2 because they both have x minus 2s. as a quantity. What are you left with when you pull that out? Yeah, you take the x squared, you take the x minus 2 out of this, you're left with an x squared. You take the x minus 2 out of here, and you're left with a minus 4. That's how you group. Which moves me on to my next type. This x squared minus 4 and this x squared minus 1, they can both be factored even further. You should always, whenever you factor, look within each bracket and say, can I factor more? You can factor here. That's called a difference of squares. It has 2 terms. So this is really ugly. I'm sorry. How do you factor x squared minus 4? Okay. To factor a difference of squares, it is just by memorization how you do it. Okay. You go bracket, 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 bracket. You square root the first term. This is by the way, no one in the center can factor difference of squares. You never recognize it. It's something like there's something in the air here because no one ever finds them. But when you have 2 terms, it's difference of squares. You square root the first term. What's the square root of x squared? X. You put a plus, you put a minus. And you square root the 4, so you get 2 and 2. Okay, so you get x plus 2, x minus 2. So if I gave you 9x squared minus 16, let's make it harder. 9x squared minus 16 y4. Okay. If you were to factor that, you square root the first term. You put a plus and a minus. And you square root the last term. So you get plus 4y squared. Okay. What if I gave you this? X fourth minus 1. Actually, let's do one before that. How do you factor this? X squared plus 9. If you said x plus 3x minus 3, you are incorrect. You cannot factor this. It is NF or not factorable because this is not a difference of squares. A difference of squares means that there has to be a minus sign in between. If it's a plus sign in between, you can't factor it. Okay. Now I'll move on to this. If I gave you x fourth minus 1, this does factor. You can square root x fourth, and you can square root 1. So you get bracket, 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 plus minus. What's the square root of x fourth? Yep. And what's the square root of 1? Good. But whenever you're factoring, you have to look within each bracket and see if you can continue to factor. This one does not factor because it has a plus sign, but this one does. So it is x squared plus 1. If I ever don't touch something in math, I have to recopy it. And then x plus 1, x minus 1. Cool? That is difference of squares. I will erase in order to do trinomials. Do you have this? Everyone has this? Good? Okay. All right. Trinomials obviously has 3 terms. That's the way you recognize it. But there's a difference in method. You can have something like this. Or you can have something like this. This is an easy trinomial. This is a hard trinomial because the number at the front, A, we call this A. It's the leading coefficient. This isn't one, but then this one is one. There are 2 different methods for solving these, or for factoring these. For an easy trinomial, you have to find 2 numbers that multiply to the last number C and add to the middle number B. But on a hard trinomial, you have to find 2 numbers that multiply to the link between these 2, like if the product of these 2. So 2 times -6 is -12. You have to find 2 numbers that multiply to -12 and add to -1 still, the middle number. So when there is a number out front, it is a hard trinomial. And to figure out what your product and sum is, for your product, for the 2 numbers that are going to multiply, it has to multiply to these 2 multiplied. Okay, the product of 2 and -6. This is called an easy or a simple trinomial because once you think of these numbers, it's really straight up on what the answer is. So what are 2 numbers that multiply to -4 and add to 3? If you do not come up with your numbers in the first 7 seconds, you should be writing out factors. So for 4, what numbers multiply to make 4? 1 and 4, 2 and 2, and you're back around. Okay? So obviously what numbers are they're going to be? 2 and 2 can't make 3. 1 and 4, but one of them has to be negative because you have to multiply to make -4. Which one's going to be negative out of that? Yes, very good. -1 times 4 makes -4. -1 plus 4 makes 3. Always double check them on your calculator if you're not great with integers. The reason why this is called an easy trinomial is because all you do for the answer is you take the square root of the variable at the front, so x squared, obviously the square root of it is x. It becomes x minus 1, the first number that you had, and x plus 4, the second number that you had. Okay. If I had, for example, x squared minus 4xy plus 3y squared. So this is an example. This is an example. This is still a factorable trinomial. Okay? It has 3 terms, and it's still easy because the number at the front is 1. Okay? You still have to find 2 numbers that, in this case, multiply to make the last coefficient, 3, and add to the middle coefficient, -4. So we got the reverse of this. What 2 numbers multiply to make 3 and add to make -4? Yeah, there's only 2 numbers that multiply to make 3. It's 1 and 3, right? Like 2 and doesn't work. So it's obviously got to be 1 and 3. But 1 and 3 cannot be the answer because 1 plus 3 does not make -4. So it's got to be -1 and -3. Because when you multiply 2 negatives, it makes a positive. How does that change how you factor this when you have y's in here? Well, think about the fact that Factoring is the opposite of expanding and simplifying. So we need to be able to create two factors that if you FOIL out, will create this. Well, it should be x minus 1y and x minus 3y. -1 and -3 were the numbers we came up with. Why does this work? Because x times x makes that x squared. Minus 1y times minus 3y makes that 3y squared when we FOIL. Okay? So when you have letters attached to the third term, the square root of this letter goes here on the second part of the binomials. Okay? Last thing in basic factoring is hard trinomials. Think about, again, we have to find two numbers that multiply to -12 and add to -1. What are your numbers? They are oh so popular. Kind of. Yeah, I've been using them over and over again, right? That does not look good. So -4 and +3. The numbers of the day here. But this is called a hard trinomial because there's a harder method behind it. What we use is something called the ratio method, okay, to figure out what this looks like. We know it's going to be bracket, 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 bracket. We know it's going to be like x here and x here. We just don't know what numbers will go here. Okay? It can't just be 1x and 1x the way that these were. Because when you FOIL out, how are you going to get 2x squared? X times x makes x squared. So something's got to happen at the front. So what we do is we use ratio method. You take that a value, which is not 1 this time, and you write it over top of the numbers that you came up with. So you take the a values and write them over top of the numbers that you came up with. And you reduce any fractions that reduce. Okay, you reduce if you can. So 2/3 doesn't reduce. Remember, we were doing 16/12 before, and that reduced by 4. 2/-4 does reduce. It reduces by what? By what? You can divide them both by what number? 2, yeah, good. So when you divide 2 by 2, you get 1. When you divide -4 by 2, you get -2. So now the non-reduced one is the one, once you fully reduce, these are your two numbers. 2/3 and 1/-2. Again, that came from writing the a value on top. So what is this factor to? 1x minus 2 and 2x plus 3. These numbers are what go here. Okay? So you get 1x minus 2 and 2x plus 3. And that's how we factor. Basic factor. Of course, you don't forget to common factor first if you can. And you'll need a lot more practice with hard trinomials. Okay? All right. Last thing in this module is advanced factoring. Advanced factoring is when you take the 5 basic factoring and you make it even harder. Okay? So an example of that would be this. If I gave you x squared, let's do, sorry, x minus 2 squared minus 9y squared. Okay. The question I would ask you is, 1, is it in descending order? Which it is. And 2, can you common factor? No, you can't. So then I ask, how many terms are there? How many terms do you see? 2. What's the type of factoring that has 2 terms? Difference of squares. There is a little trick to help you. The fact that the thing that makes this so confusing is this whole x minus 2 in brackets. So what you can do is you can say, why don't I let a letter that's not being used here, equal x minus 2? Okay? If I let a equal x minus 2, that changes the expression. And I can change it now to be a squared minus 9y squared, and factor that expression instead. So if I factor a squared minus 9y squared, well, that's a difference of squares, so it goes bracket, 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 bracket. I square root the first term to get a, and I square root the second term to get plus 3y and minus 3y. And now I can put the x minus 2 back in. I'm sorry, I should have had brackets on this. So now I put that back into my expression here, and I get x minus 2 in the place of the a, plus 3y, minus 3y. Equal signs on here. Okay. That can be cleaned up a little bit. We have a 1 in front of this bracket, in front of this circle bracket. I can expand that 1 in to get x minus 2 plus 3y. There was a 1 out front here. If there was a 2 out front, then I would expand the 2. But then I prefer this in descending order within each bracket. So you get this. A little bit cleaner. Because it was a 1 in front, it's basically like the bracket isn't there. Okay. Let's get harder. What if I had said x squared minus 2x. I need to make this up, sorry. What's the first thing I would do here? I'd make it simpler on myself by letting a equal x squared minus 2x. Right? So I'd say let a equal bracket x squared minus 2x. That changes my expression to become a squared minus 11a plus 24. How many terms are there? Ox? Yeah. Easy or hard trinomial? Easy because the front term is 1. So we have to find 2 numbers that multiply to 24 and add to negative 11. Okay, 2 numbers that multiply to 24 and add to negative 11. those numbers, I'm going to speed this up, are -3 and -8. So this factors to become a minus 3, a minus 8. But I can back substitute. I can't have a's in my final answer. I'm going to back substitute right away and put x squared minus 2x here and x squared minus 2x. Because they're 1s in front of the bracket, I don't so much need the circle bracket, but I'll put it in anyway. And then I get minus 3 and minus 8. So that looks like x squared minus 2x minus 3, x squared minus 2x minus 8. So I took out the x squared minus 2x, so it didn't have to look so complicated. And then it's not so hard to do. Does that make sense? But we're not done. Why? Because you should always look within each bracket to see if you can continue to factor. This is factorable. It's a trinomial. You can find two numbers that multiply to make -3 and add to -2. Those numbers are 3 and -1. Sorry, -3 and +1. So I get x minus 3, x plus 1. And then this also factors. It's another easy trinomial. You can find two numbers that make -8 and add to -2. It's -4 and +2. So you get x minus 4 and x plus 2. That's the final answer. Okay. Last one we'll do. What if I had given you x squared minus 6xy plus 9y squared minus 16z squared? This is about as hard as it gets. This is like the hardest type. And it's brand new to grade 11. At Holy Names, there was a teacher that called them big uglies. Oftentimes, we call it a PS-DOS question. It's a PS-DOS because there's a perfect square in here, and then it turns into a difference of squares. Your typical logic would have been that it's 4 terms. So the only type of factoring that you knew up to this point was to factor 4 terms is grouping. But if you common factor the first half, and if you common factor, well, you can't even common factor the second half, you will not get the same bracket, so you cannot group. So a new type when you have 4 terms is a perfect square difference of squares. What you do is you factor the first 3 terms, or rearrange them so that you have a factorable trinomial. This is a factorable trinomial. It's an easy trinomial in which you can find two numbers that multiply to 9 and add to -6. What two numbers multiply to 9 and add to -6? Yeah, -3 and -3. Very good. Okay? So what is this factor to? It's an easy trinomial, so it's going to be bracket, 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 bracket. Right up, it's going to be x minus 3y, x minus 3y. Because there's y's on it, that's why we need y's here. If I ever don't touch something in math, this was really messy, sorry, should have been further away. If I ever don't touch something in math, it's going to bother me. You have to recopy it. So this, which we did not work with, needs to be recopied on the next line, otherwise you get bad form marks. Now this can be written more elegantly. It can be written like this. Because this times this can be really written as this. Now we're in this situation again. Let A equal x minus 3y in brackets. Notice you don't make it squared. You just make it the bracket portion without the squared. It changes this to a squared minus 16z squared. This is another difference of squares. Square root the first term, put a plus and a minus, square root the last term. And we can write it back in. That's the answer. Okay. That's advanced factoring.